Hi, good morning, everyone. We shall be starting in today.
Hello, Ayush. Hello.
Hello.
Hello. We'll wait for 5 minutes, then we will start the session. Is it okay, Ayush?
Yeah.
Okay. Hello.
Hello.
Are you?
Yes, yes, sir. I'm audible?
Yes. Yes. We should start.
Sure.
Candidate will join. Okay.
Yeah. Just give me a minute. I'm sharing my screen.
Okay.
Yeah, I hope my screen is visible. So, welcome back everyone to this workshop organized by NIT Jalandhar on advanced multi-skill 3D modeling and simulation for engineering and biomedical research purpose. Now, without wasting time, just let me have a recap what we have done till now. So we had seen the 3D image processing software named SimpleWare, how to do the particular processing in a desktop code, how we can utilize different features to carry out the segmentation, what are the different methods to do the different types of segmentation, then ultimately modeling a finite element model, CFD model, doing the 3D printing and whatsoever. Now, in this session, we shall be focusing how we are using different technologies that are currently present and are booming right now in the market, such as virtual reality technology in the field of medical image processing, and how it is advancing and reducing the turnaround time by a significant margin. So, without wasting time, let me introduce with today's topic. So, today we shall be discussing about transforming medical imaging into interactive VR using Elucis Next software. So, first of all, little detail about us. So, we are the sole representatives of Elucis by Realized Medical in India. We represent immersive medtech solution, which is currently focusing on the virtual reality and augmented reality based platform for various causes. Our primary cause is to deal up in the medical image processing, how we can transform the medical image processing sector using the VR technology. And we have came out with this amazing platform being Elucis Next by Realized Medical, where we can do 3D reconstruction of the images with various interactive modes. We can do it in collaborative environment. So if multiple user needs to connect, they can done in a very easy and efficient manner. Now, apart from that, we also have various advantage like enhanced surgical planning. So the surgeons can directly connect from whichever place they are in a single virtual environment, come together, do the segmentation, and for the engineers to directly carry out the segmentation, as we aren't that familiar with the medical part, the anatomy, but we are familiar with the CAD applications and the research-based application like finite element modeling, how to do that. So that has been so the part of doing image processing has been reduced using VR. We can just set out the points, and in the upcoming afternoon session, I shall be discussing in detail how we are using the tool, what are the basic tools that are present in the software itself. So moving to the next slide. In this session, we shall be focusing how the immersive VR technology is fundamentally changing the way that we have usually used the DICOM datasets for. Apart from DICOM datasets, since we had seen in the other software how we have done the image processing of any 2D image stack, so the same can also be carried out uh, in Elucis Next. We have the option of Nifty segmentation too. So even if there are Nifty images, we need to connect to the fact server. All gets included in it. Apart from that, since we have already discussed the traditional DICOM imaging, now we shall be focusing on the 3D environments, how we create the 3D environment, how we calibrate the 3D environment. That is the XR environment that we are working on. That corresponds to extended reality, which is a one step ahead from the virtual reality. And then we have the concept of augmented reality too, wherein we can physically interact with our own hands and go inside the virtual environment and do all the particular modification and changes. Now, Let us take a quick overview how the VR can be used in medical imaging, what are the different principles that can be used, and what are the different options that we will be getting while we are doing the segmentation. The first one is that we can do easy the dynamic 3D visualization of any anatomical data. So for any CT dataset that we are working, in the same CT dataset, we can clearly visualize the bone part as well as soft tissue. So we just need to then turn the window and level tool to magnify and to pinpoint our requirement. And once the pinpoint requirement is given, we can have the visualization of multiple image modalities to turn the same dataset that we are providing. Apart from it, later comes the particular implant designing and implant positioning part. Earlier on, we used to rely on 2D, 3D methods. Now, what we can do is if we have created an implant and we need to see how the positioning is there, how it's performing. So, what we can do is we can directly take the particular implant through our hand. Through our hand means we use the software using controller. We can also use it directly by our hands and by our finger control, but it's a slightly tough to adjust with the fingers in the virtual environment. So we have the options of controllers that I'll further show. So I'm just turning on my camera to show the same. Yes. So when we are talking about VR, so this is our primary VR headset that we have and we use to operate and go inside the virtual environment. And then we are also supported by a left hand controller and a right hand controller. So these are our control mechanisms through which we can navigate and use various tools that are present in the software. So this is just an highlight and I'll tell in detail how to set that up. And it's quite an easy process to set the particular VR headset and utilize in the software. Apart from this new approach in using the software in VR, we are also given with an added advantage in Elucis to directly use and operate the software in the desktop-based environment. So if we are familiar with the desktop-based and we don't have a VR headset, then too it's not an issue. We can operate the software in the normal desktop environment like our laptop or any computer that we are having. Now, the software can also be used for basically a 3D complex data set. Directly, we can just go to the specific point of defect, we can identify the defect, and there is a reduction in the 3D printing. And when we say the reduction in 3D printing, it tells us the reduction in the cost by a huge margin. Because when we are doing the 3D printing, there's the material cost and there's the printing cost. And usually a 3D printed material takes for a medical device, for example, a heart. It takes around 12 to 24 hours to have a high fidelity model created out. And if we just need to check the particular defect at what position it is, it's quite costly too. So it costs around 10 to 15,000 just for a hard model to get printed. That's the printing cost. To reduce out this cost, what we can do is we can directly load the data set in our viewing section, and once we are cross examining the data set, we can easily modify the region, and then we can work on the same. And once we are working on the same, we will have a greater knowledge about whatever tools that are being presented. Then, coming on to the next slide is the importance of using this particular tool or interactive in the medical planning. So once we have imported the result over here, what we generally get is, let me oversight that. So whenever we are importing the data set, what we generally get is a particular view section through which we operate the data set for. There is the level tool, then there's the window tool, and there are various other options to directly generate a volume rendering of the data set. So even if we don't require the segmentation, we can directly generate the particular soft tissue generation from here, or if we need to visualize the abdominal region, that too can be done. We just need to select out the different presets that are being presented. And once these presets are selected, we can work interactively with the poly. So if we need to use a CT lung, we can directly set the window and level of the same, and we can go to the specific point of correction. Since this is shown in the 2D, so the data set is not that clear, but once we go into 3D view, either in the and we are on the virtual environment, the data
gives us more
gives us
clarity.
more clarity,
And then
and then
ultimately we have a
ultimately we
proper
have a proper
decision making
decision
of the
making
same.
of the same.
And even if we
And
are
even if we
developing
are
a new
developing any
CAD,
CAD
we
implant,
can
so we can
have the
have the
precision
precision
around
around 0.001
0.001
millimeters
millimeters.
of efficiency.
So
So
the
the
particular
particular
models
models
that
that
are
are prepared
highly
are highly
defined models,
defined
and we
models,
are also
and we are
given
also
an
given
option
an
to
option
design
to
our
design our
design
own sets of designs
directly in
directly
here.
in
So
here.
that
So
further
that
helps
further
us in
helps
our
us
task.
our task.
Now,
Now,
coming
coming
on
on
to
to
the
the next
next
point
point
and
in
next
this
part in this
presentation, that
presentation,
how it
that
is
how it
enhancing
is enhancing the clinical
with the
workflows
help of
with the
VR
help of VR
technology.
technology. Now,
To
to
understand the
understand the
anatomy earlier
anatomy
on,
earlier on,
what was the
what was
standard
the
approach?
standard approach
Was a
was a
cadaveric
cadaveric
approach
approach
where the
where
cadaver
the
sample
cadaver
was
sample
provided
was
and
provided and the
students will learn
students
about
can learn about
anatomy.
anatomy.
For
But
engineers,
for
it's
engineers,
quite
it's
difficult
quite
to
difficult to
understand it that way.
understand it that way.
We engineers
We
use
engineers
the
use
tag
the
as the
tag as
primary
the
source
primary
to
source to
understand
understand
any
any
technology or
technology
any
or
other domain
any
that
other
we are
domain that
working
we
on.
are working on.
And we
And
are being
we are being
one
the
such
one
domain
such
tag
domain
that
tag
can be
that
used
can be used and
can be
can
further
be
relied
further
on
relied on
due to its
due
ultra
to
high
its ultra high
efficiency.
efficiency. Now,
Whenever we are
whenever we are
operating a
operating
data
a
set,
data
we
set,
need to
we
have a
need to
greater
have a greater
interaction with
interaction
the
with the
data set.
patient data set.
This is
This
further
is
helped
further
by
helped
the
by
VR
the
controller.
VR
So
controller. So
in the camera
in the
earlier on
camera
I had
earlier
shown
on, I had
the
shown
left hand
the left
controller.
hand controller.
This is one
This
such.
is one such.
So we need
So
to
we
have
need
a
to
good
have a
control
good
over both
control
the
over both
controllers
the
to
controllers to
navigate between the
navigate
data
between
set.
the data set.
We can cut
We
the
can cut
planes at
the
any
planes at any
specific point
specific
of
point
design.
of
So
design. So
even if we are
even if we are
designing that
designing a
spine fixation,
spine fixation,
that can be done
that
in
can
a
be done in a
fraction of
fraction of
seconds. Then
seconds. Then
if we are
if we are
segmenting out any
segmenting out
plant
any
data
plant
from
data from a
image data,
image data,
that too can be
that too
carried
can be
out.
carried
We
out.
can set
We
out
can
a
set out a
threshold value
threshold
over
value
here
over
and
here, and we can also set a
display the
display
particular
the
same
particular
threshold
same
value
threshold value
over here. So we
over
can
here.
have
So
a
we
clear
can have a clear
visualization
visualization
of
of
the data
whatever
set that
data
we are
set that we are operating on.
and it also
And it
provides
also
us
provides us
user-friendly interface.
user-friendly interface.
So
So
even if there is
even
a
if
need to
there's a
learn, we
new
can
user,
learn
he can
software
learn software
in
in
a short
a
span
short
of time.
span
In
of time. In
2 to 3 days,
two to
we
three
can
days, he
get
can
familiar
get
with the
familiar
tools
with the
that are
tools
present
that are
in
present in the
software range
software range.
and the
And the
segmentation time that
segmentation time that
usually
usually
took
took
around
around
30
30
minutes,
minutes, 1
1
hour
hour
using manual segmentation for complex data sets
gets reduced
gets
down to
reduced
2
down to
minutes
2
or
minutes
either 1
or
minute.
either 1 minute.
So we can
So we
directly
can
work on
directly
the
work on
part
the
that is
part
much
that
more
is much
required,
more
that is the
required, that is
implant
the implant
part.
part.
Or even if we
Or
need
even if
to
we need
develop
to
a
develop
model,
a
what
IP
we can
model,
do is
what we
we
can
can
do is we can
export out the
export out
particular
the
file
particular
into
file
STL
into
and
STL
OBJ.
and OBJ,
And later on the
and later
STL
on the
files can
SQL
be
files can be
imported with
imported with
ANSYS
ANSYS
and
with
we can create
we can
out a
create
mesh.
out a mesh.
A normal
A
mesh can,
normal
a
mesh can
small
a
surface
normal
mesh can
surface
also
mesh
be
can
created
also be created
in
in
Elucis
Elucis
itself,
itself,
where we can
wherein we can
define the node
define the
sets
node sets. We can also
shells
define the
that
shells
are
that
required.
are required.
But to develop
But
a
to
high
develop a high
quality
quality
FE
FE
model,
model,
we
we will
require
be
the need
requiring the need of a thicker sensor
for doing
for
customization.
doing the simulation too.
Coming on to the
Coming on
next
to the
slide
next slide
is the
is the
capabilities
capabilities, further capabilities of the tool.
so we
So
have
we have the
integration of
integration of
Elucis with the
Elucis with
existing
the existing
system. So
system.
even if
So
we
even
are
if we
familiar
are
with
familiar
any
with any image processing
software,
software, for
for
example,
example,
Simpleware,
we
and we need to
import the file
import the
from
file
Simpleware
from Simpleware to
that can
Elucis,
be
that
done
can be done in a very easy and efficient manner.
what we just
What we just
require is we
require is we need
require STL
require a
file.
STL file, and once the STL file has been
Created,
created,
or even if we
or
have
even
the
if we
DICOM
have the
file, we can
DICOM file, we
directly
can directly bring in
use the software
Elucis
and
software, then we
do the
can
reverse
do the
engineering.
reverse engineering of the data set,
And we can
and we
further
can further
work and
work
enhance
and enhance
whatever image
whatever
data
image
set we
data
are
set that
working
we
on.
are working on.
This also
This also integration also
allows us
allows us
to
to further
enhance the
enhance the
efficiency
efficiency
and
and
improve the
improve the
quality of
quality of
whatever product
whatever
we are
product that
delivering.
we are delivering.
We can directly
We can
interact
directly
with the
interact with the
set over
set
here
over
as you
here,
can
as
see.
you can
We
see.
can go to
We
the
can go to
specific
the
points
specific
of
points of
modulation
modulation,
and
and
we can
we
correct
can
out
correct
the
out the smallest
smallest
of the
defect.
smallest
We can
defect. We can
remove out
also
the
remove out the region that is not
required.
required,
So we have
so
the
we have the
accuracy at the
accuracy
highest
at the
level.
highest level.
Now coming on to
Now
the
coming on to the
healthcare area,
healthcare
how
area,
it's
how
we
basically
are used
VR
in
is used in
clinical
clinical
settings.
settings.
So
So
currently
currently
there is
there is
also
also
a team
a
that is
team that is
working
working
directly
to directly
integrate the
integrate provide the VR-based volume rendering generation directly to the CT scan or CT scan machines or the MRI scan machine, wherein whatever data set would be loaded in the CT and MRI when the scan is completed, the data can be directly visualized in the following headset. And the visualization is quite immersive. We can just go inside any cross section. We can view the particular cross section that we are working on. And I say one more thing that it is not just limited to the
medical data
medical
set.
data set. Even if we need to do any sort of material reverse engineering, since it is working on the threshold based approach,
So we
so
can also
we can
use
also
for
use for
material data
material data set. I used the software for one such rock sample rock 3D that I was having,
and the
and the
result accuracy
result
was quite
accuracy was
high.
quite high.
And
And
further,
further, this also tells us
we
that
are
we are
just
just
limited
limited
by the
by the by
by
our
our thinking.
thinking. If we expand our thinking, we can
Use the
use the
software, use the
software, use the
technology
technology
in
in
domain
any
that we
domain that
require.
we require for.
So
So
now let us
now
discuss
let us
about
discuss
the
about
different
the
tools
different
that
tools
are
that are
present in
present
Elucis.
in
There
Elucis.
are
There are
different
different sets of
operations,
operations,
modes of
modes of
operation
operation
that we can
that we
further
can
use
further use to
further work in the
further work in
software.
the software.
The first one
The
being
first
the
one being
create
the
mode of
create mode
operation.
of operation.
This is the
This
most
is the most
detailed mode of
detailed mode of
operation that
operation
one
that
user
one
can
user
use.
can
It
use.
carries
It
all the
carries
features
all
of
the
the
features of the
software.
software.
No feature has
No
been
feature has
limited
been
over
limited
here.
over here.
Before that, we need
Before
to
that,
set
we
an
need to set
XR
an XR
environment. That
environment,
is to
that is
connect
to
our
connect
VR
our
headset
VR headset
with our
with
software
our
tool.
software tool.
And the second
And the
mode
second
being an
mode
engage
being an
mode.
engage mode.
Engage has some
Engage has
limited
some
features.
limited
For
features.
example,
For example, if we are director
we
surgeon,
might
so we
not
might
require
not
to do the
require to do the
segmentation
segmentation
as that
as
part is
that
carried
part
out
is
by
carried out by a biomedical
biomedical
engineer or mechanical engineer.
so once
So
the
once
particular
the particular
segmented model is
segmented model is
prepared,
prepared, the
the
surgeon can directly use and
basically work
basically
on
work on the
directly
software directly using the engage mode.
and in the
And
create
in the
mode we are
create mode,
given
we are
with
given with
multiple
multiple sets of
modalities. Either
modalities.
we can
Either we can
do the
do the
segmentation
segmentation
using a
using a
desktop-based approach
desktop-based approach
or using a
or
VR.
using a VR.
Apart from
Apart
that,
from that,
in the create
in
mode we
create
are
mode,
also
we are
given an
also given
option
an
to
option to
design
design any
uh,
sort of
CAD parts
CAD parts
in
of
all the
in
degrees
all the
of
particular
freedom.
6 degrees of freedom. So
Like
we are
full
given
virtual
full
environment,
virtual environment, and when we are
the
doing the
painting
painting
in a virtual
in a
environment.
virtual
It's
environment,
basically
it's
a 3D
basically
mode
a
of
3D
paint
mode of
where
paint.
we
So we
can
can
use
design
of the
any
shape
sort of shape
directly
directly
with single
with
clicking
single
operation.
clicking operation.
That will
That
further
will
show
further
how we
show
can
how
use
we can
that
use
for
that for
any
any
cranial
cranial
implants.
implants. So
For example,
for
if we are
example, if we
designing
are
a
designing a
cranial
cranial plate
and we don't
and
have
we
much
don't
time
have
and
much
we
time
require
and we
high
require
sets of
high sets of
efficiency.
efficiency.
So we can
So
set
we
out
can
the
set
control
out the
points
control
over
points
which we
over
can
which we can
modify
modify
different
our
lines
different
of
lines of
operation.
operation.
And once the
And
lines
once
of
the lines
operation
of
has been
operation has
modified,
been modified,
we can
we can
directly work
directly
on the
work
following
on the
data set.
following data set.
That being the
That being the
engage
engage
section.
section.
Here,
Here, whatever
whatever
segmented
segmented
part
part
that
that
is
is
.p equal
.p
file, that is Elucis
file
project
that we
file
are
that
having,
we are having,
we can directly
we can
open
directly
that in
open
the
that in the
engage.
engage, and
Once it is
once it
open
is
in the
opened in
engage
the
section,
engage section,
we can work
we
with the
can
data
work with
set.
the
We can
data set. We
again
can
do
again
the
do the
reslicing and all,
reslicing and all,
but we
but
can't
we
be
can't
doing
be
the
doing the
particular design
particular
generation
design
part
generation part
as of now
as of
in
now
the engage
in the
mode.
engage form.
In the create
In the
mode,
create mode, one
that
more
we
option that
get is
we get is
strength
the
planning.
strength
Even
planning.
if we
So
are
even if
working
we
with
are working
high
with high
fidelity
fidelity
cardiovascular data
cardiovascular
set,
data set,
so that too
so
can be
that too can be
segmented out
segmented out
with an ease,
with an
and
ease, and once that is done,
we can
we
further
can further on
work on
work
any
on
section
any section that we require for.
now,
Now,
there is also a
there is
need
also
to
a need to
ensure
ensure
the particular
the
image
particular image
quality once it
quality
is
once it is
taken in a
taken in a
XRP or
XR
a
view
VR
or a
view,
VR view,
that it
that
should
it
be
should be
accurate
accurate
and
and
precise.
precise.
So to cover
So to
that
cover
out,
that out, what we have is
we have
we
one
have
other
one
sets of
other sets
operation
of operation
where we can
where we can
calibrate the
calibrate
particular
the particular
image that we
image
are
that we
having
are having
and the color
and the
region
color
that we can
region that
see
you can
in the
see
orange
in the
color.
orange color.
So
So
it
it
basically tells us
basically
the
tells us the
spacing
spacing
behind the
behind the
policy.
falling scene. So let me just zoom in.
And if I
And if
move
I
it around
move it
here,
around here,
you can
you
see
can see
there's a
there's a
gap in the
gap
voxel
in
spacing.
voxel spacing.
So this
So
voxel
this voxel
gap allows us
gap
to
allows us
further
to further
modify and
modify
configure the
and do the
segmentation
segmentation
where we can
where we
directly
can directly
work on the
work on
smallest
the
of the
smallest
smallest
of the
parts. So
smallest part.
no
So
feature
no feature
gets
gets
missed while we
missed
are
while we
using
are
this sort
using
of
this sort
approach,
of approach,
wherein we can
wherein we can
calibrate the
calibrate the
set
data set
according to the
according to the
specific
specific
requirement.
requirement.
And
And
whenever we are
whenever
using
we
this
are using this
calibration based
calibration
approach,
based approach,
it
it basically
does
what
is
it does is uh,
since our
since our
eye is
eye
in the
is in
VR
the
view,
VR view,
we
so
have a
we have
65
a 65
centimeter gap
centimeter
from
gap from the
the actual working
actual working
environment.
environment.
So
So
it does
it
the
does the
respacing in the
respacing in the
millimeters according
millimeters
to our
according to our
eye
eye
strength
strength
values that we
values
have,
that we have,
and we can
and we
further
can further
modify the result
modify the results to the smallest of the value. Over
Over
here,
here,
whenever we are
whenever we are
identifying
identifying
different
different
regions,
regions,
it's of
it's
the
of the
foremost
foremost
importance
importance
that
that
each and
each and
every
every
feature
feature
gets
gets
highlighted
highlighted
individually. So
individually.
you
So
can see
in this
in this
particular data
particular
set,
data set, we can easily observe the list stage data set. We can also observe the lungs, the nodes,
nodes,
the
the
branches
branches,
inside the lungs can be
and
observed.
here the
And here
cardiac
the
data
cardiac
set
data set can also be further observed. The aorta can be seen, the left ventricle, the right ventricle can be easily seen down.
and the spine
Then the
part
spine part can
is
also be
over
seen
here.
over here. So once we do this sort of approach, we won't be missing any part, and the calibration quality is also quite high. Moving on to the next part is the particular open project view. This is the first view that we get while we have opened the dataset. This is already a segmented model, so when we open the software, we only see the DIFOM file in one such view. Here we have two modes of operation. Either we can click over this, show desktop camera position in headset. So whatever current view that we are seeing in the desktop view, that is the screen of our laptop or our computer, we will be seeing the same screen in the VR headset and the other one being following the point of view. So following the point of view is one such important feature wherein what we can do is whatever we are seeing in VR headset can be directly copied out in our screen. One more added advantage that we get is the recording section. So even if we need to create screenshots for any part, we can directly click over here in our controller itself and carry out into the screenshot generation. Apart from that, if we need to do the recording of the whole section, so that too can be done in a very efficient way. We can record the whole sessions. We can also have our input as a voice. So even if we need to insert voice memo, that can also be done, and we carry out the segmentation of the same. This is the desktop view that we get. Over the left hand is the project information section. It carries a lot of information over here. The first one being the particular patient name and medical record associated with the we have other record options over here. Then whatever particular project that we need to import, whatever EEP file that we need to import or STL file, OBJ file that we need to import, we can do it from here. Then whatever project file that we have worked on. So let's move a slide back. So whatever project file that we have worked on, if we are requiring to do the export of that, we can do it from here. The desktop-based segmentation can be clicked over here, and then we will be getting the 3-2 reviews and 1-3 reviews that we are generally familiar with. Here we have the collaboration feature. So if we need to connect multiple users into a single virtual environment, so that can be carried out from this particular menu option. Then we have a standalone XR connectivity. If we need to send only the particular file that can be directly opened in a VR headset, so we can also send the particular file and directly open that in a VR headset using this standalone XR device collaboration. Here is the setting options to further modify whatever settings that we are working on. Like if we need to set out the VR headset, we need to set out the virtual environment quality, we need to set it as an augmented reality. All the particular features can be carried out from here. And the last part we have the save report. So whatever part that we are working, we can directly save it from this save section. Now, coming on to the next part is the scene viewing option. Once we have imported the dataset, we are further given multiple options. So when we will be going over here, we have this left-hand section. Then we also have a right-hand section that carries various options. So this is a structure and model generation over here. So whenever we are creating a new model or a new structure, we need to check this particular option on, and then we can carry out the model generation. Here is the recording section where we can create out the snippets or we need to create out the video recording that can be captured from here. And over here we have the scenic visualization. So the next slide carries and shows the scenic visualization option that we have. In the scenic visualization, we are furthermore given additional options such as source to limited radiograph, where we can generate a radiographic image. So here, since we are dealing with an target data set, it helps us to generate out the X-ray view of the data set, and we can have the precise model generation of the same. Whenever we have generated multiple structures within a single viewing option, so we can also select each and every part to move it separately. For example, if we need to carry out this trachea segmentation and we need to place it somewhere else, so we can directly select this particular trachea portion. Once this particular portion has been selected, we can move and navigate according to wherever position it is required for. Similarly, each part can be done. We are given the three modes of operation. We have the one being the translation, where we can translate the part in the X, Y, and Z axis. Then we have the rotation, so we can rotate it along any degree of axis to from 0 degree to 360 degree. And then we have spin to basically rotate it around this particular Z axis. So we have all these options, and we have a collaborative mode wherein multiple users can connect in a single window, and if the particular one user is moving out this part, other can work on this part. And the extra precise option when we are enabling this, so the moving strength is reduced by a significant amount, so that whenever we are placing any implant, for example, it's to the most precise of the location. This I'll further show how it is helping. Uh, I'll take the same pelvis example that was taken on day two, and we had done the segmentation using the 3D image processing software and prepare how we can carry out the same set of operations in a VR view. And then we have 1 millimeter and 1 degree of operation, wherein the precision can be taken to the 1 millimeter and 1 degree of operation. And whenever we are moving any part, that can be separated out. Here we have furthermore four options where we can move in the plane, so we can have different sets of plane to be created, naming the clip plane 1, clip plane 2, clip plane 3, up to clip plane 10 I have worked on, but we can have furthermore extension up to 50 planes in single data set. And if there are more than 50 planes, we can definitely work, but it will also further increase our memory size requirement for that. Then we have the move active model. So whichever part that we have selected as active part, we can move the particular part. We also have a move active structure. So whichever structure that we have created, we can move that particular part. So a model or structure is uh, a sub-part of a model. The model may contain various different structures like trachea, then for heart we have the aorta or the lungs. These are the different structures that are carried out in a model of the particular soft tissue. Then we can also have a new model created as particular hard tissues like the bone and other orthopedic parts that can be created, and furthermore the labeling can be done. So labeling can also be done at the final stop value. Now, whenever we are operating the software in a VR view, we need to use the particular right hand. That is my dominant hand. So we can select the dominant hand in the software. So if we are left hand dominant person, so they can select the left control as dominant hand, and they can operate accordingly. Here we are given different sets of controller buttons that we can use. So let me show. So for example, if I am using this sets of operation, and this being my dominant controller over here. So there are different buttons in this mouse. So this being the dominant button that we would be using to open the particular menu option. Now, once we have loaded the menu option, we have the next task. The next task being to navigate through different options that are present. So in the navigation, you will be further seeing that we have one option of grabbing. So whatever surface that you are working on, the active surface, we can grab the surface, we can move it to any point. We just need to stick on the particular option, and then we can navigate the surface to the whichever extent that we require. Then we have the anchor point setting. So we can set out a specific part as anchor, and corresponding to that, we can revolve all the particular surrounding units to the precise of value. Then the precision mode that we have selected out earlier over here. So this is how the precision mode would work in a VR view, where we need to just click on this precision mode option, and we can work accordingly. Then we have a clipping of sphere. So whenever we are requiring to a new plane for generation, we can click on this clip sphere, and a new plane can be generated. Then furthermore, to set out the VR environment, the first option that we need to always click is the clip surface to set out the surface according to our specific requirement. Once we have clicked on this clip surface, we can go and click on the trigger button to just place out the surface in front of our eye, so we can navigate and work accordingly. Next up being the surface configuration to check out the surface volume, how much total volume it is occupying, what are the different number of elements that it has. We can check it from the surface configuration information. To again load this menu option to reconfigure it, we can click over this menu, and in the camera option we can further rotate it along any axis that is required. The next part being the modeling option, where we have the option of adding, so we can add different sets of structure, like I told in the last slide, where we can mark up different boundaries like trachea, aorta, or any other soft tissue. We can add different region. If we have selected and done the sculpting in the VR view, and we are not satisfied with the result, so what we can do is we can remove the part that is not required using the subtract option. Similarly, the let me have a quick recap that we have used the region growing in simple way, where we used to grow the region on the basis of threshold value. Whenever we have assigned a threshold value, according to it, whenever we are pressing on certain region, it used to grow the particular region that was shown in yesterday's session for the blood vessel segmentation. The same can be option. The opposite of this growing is the shrink. To shrink out the size, if we have included some noises to existing structure, we need to remove out the noise. We can use the shrinking operation. Then to smooth out any surface, we can use a smooth operation. We can select a part of whole surface where for which we need to do the smoothing, and we can select it out. And then we have a denoising filter, so we can directly reduce out the noise using the denoise filter. And generally, the big noises that are present, metal artifacts that are present, gets removed in a single click operation. Next up is a measurement tab, so we can do the direct measurement in the VR view. Then we have the select option, so whatever measurement that we have done, we can select the particular measurement. We can rename it with, using the markup option. We can also delete any selected measurement that is not precise, so that too can be done. Then if we need to add a voice memo to annotate that this part corresponds to this region, this part corresponds to this region, this is the tumor region that we have identified in our data set, that can also be done using a voice memo selection. Then whenever we have developed a model and we are now working on a surface file, that is our STL file or PG file, what we can do is we can use the following options to further modify any STL file that we have created or worked on. Apart from that, in the left domain hand, we have the particular option of designing. So we can also do any structure designing directly in the VR view. Since it is included in the latest version, this was released last week, so it is not included in this presentation. But I shall be also showcasing the feature in the upcoming session. Now, let us come across some real world application and how it is currently being used uh, for the 3D surgery. So whenever we are working on any data set, either we can use it in a text view or whenever we are going into VR, we will be having a particular ghost view of the same while we are doing the segmentation. So the segmentation accuracy is the most precise. We can also manipulate any patient anatomy, so we can move the hard part from this position to this position, so we can furthermore see the detail of the other structures that are present, like the lungs part or the nearby arteries that are being present. Each and every part can be uh, checked out. If we need to clip the surface of one specific point, that can be done, and once the clipping is done, we can view the internal structure of the same. Then we can also enhance the standard procedures that we used to have. We can connect multiple systems using a remote collaboration and come inside a single environment to do any sort of planning. Then the software can also be used for various training simulations and various other education, can be used as an education tool, wherein if we need to understand about a part, we can work on a dummy model, and we can also insert the haptic feel of this particular part in the VR headset. So the efficiency is of the most precise value. Then we have its normal use case, where we can directly convert a DICOM to a VR-based segmentation. Here we can interpret the data for any source engagement. It can be specifically used for the research part, where we can work on the specific portions. Then seeing the same in this particular VR view, where we have also the implants. So, for example, this was a total knee replacement TKR surgery that was being performed, and in this TKR, the implant, since it has a higher grayscale value, this part was identified, it being positioned inside the data set. corresponding to image data. And furthermore, the precision is being considered and a plate is being set. This all is done in the software itself. So the particular manipulation and working of data set becomes quite easy. Now, coming on to the conclusion over here, that as we have discussed, the VR is the most booming technology nowadays, and we can see people walking across using a Apple Vision Pro, Meta Quest headset to see and explore different features. So we are, once we have any VR headset, we are not just limited to use it in the medical field, since it is the VR headset comes as a general view. So it doesn't mean that we will be only using a VR headset for medical purposes. We can use it for any purpose. Uh, for example, even if we are doing an engineering part, we need to develop the particular design directly in the VR. That too can be done. Further, if we require any modifications to be done. For example, we have taken an intensity example over the 30. Here we have seen how to do the reverse engineering application. So the same city can also be taken in the VR view. The part detection can be done. So it will furthermore reduce on the cost, because earlier on we used to rely on the particular scanning, again scanning the part, then to compare the scanned part versus design part. So this can be further removed to a greater extent. They might not be requiring again new prototypes, as the prototyping the parts of prototype will get reduced by significant margin, and thus whatever wastage that is created, we can also reduce down the particular wastage directly, and ultimately saving the environment by reducing the waste material usage. So these are the different approaches that we can use for. Now, to use such a high-end VR based software, we require certain high advanced systems to for the software to work on. So the current system that I am operating the software on is a i5 12th generation laptop. So it's a laptop, but it's not a desktop. It has RAM of around 16 GB, but the software works fine. But it has a graphic cards of RTX 4060. So it is a high-end graphic card, and the headset that I am choosing, that I've shown right now, is a Meta Quest 2. Here we also have the pixel count per eye. Then we can set out the particular field of view. The particular frame rate that is generally designed for using in a VR-based environment is around 80 hertz to 90 hertz. That's more than sufficient, and the hardware that we have has the maximum frequency of around 120 hertz. So this is all adjustable. Once we are setting up the environment, we need to go over here. We need to do the quest to setup. This I'll be just showing uh, after this particular presentation how to do the setup of environment, and once the setup is done, we shall be also seeing how the application area varies for medical purposes using VR. So this is the email ID. So if anyone has any queries related to VR technology in the medical, they can contact over here. Also, you can follow us on LinkedIn for such informative session. But let me just quickly show how we set different sets of environment in the Elucis software. So to set up the environment, generally what we do is we go over here. Once we go over here, uh, we will be first getting a link over our mail ID, the registered email ID that we are having. Once that is done, the process of installation is quite simple. We just, yeah. Anyone has any question? Yes, please. You've raised your hand. Yeah, so just it's a 10 minutes of overview. I'll just give a quick overview. After that, I can check out the questions if there are any. Just to do the installation, how to just to navigate and import data set. It's a 10-minute process that I can show. So the installation procedure is quite simple. We need to run the software as administrator, and once the software is run, we move on to the next part. Here, since we will be going for research license, I just need to click on agree. Here we can check out the research purposes. So this is next is basically developed for research purposes, wherein we can navigate different parts. Currently, no VR headset is connected. To do so, let me just have it connected to them. So I need to connect to that for that. So we go over here and we go over the metaverse link, right? So link setup that will connect the software, the MetaLink software with the VR headset. We just need to click over here. So since my device is already set up over here, let me first remove this particular device. So the how to do the particular insertion, how to do the particular setting. Here we do it. I'm just turning on the camera. So this is my link cable where we connect the port of USB Type C that we connect. Then we insert in the software over here. Since I need to also see how I'm doing the linkage, so I just go inside the link software. Here it is showing that's connected. It has auto once we connect the link cable, it automatically detects the what hardware is connected. So once it's done, I can directly use the headset over here. If it's showing as connected, it's connected. Let's use the device. Whenever we are selecting the device, so whatever headset that we have, we just click over it. Clicking on continue, then we need to select the method. So there are two methods. Either we can connect this and this particular desktop system over a cable network using IO-Link, or we can have a link cable which is the differential device while we are operating on software. Once that is done, we need to go inside the headset and choose the role of controller. Using the controllers, I'll navigate through the process, and one pop-up screen comes in my headset where we can just connect a particular VR headset with the desktop. So it's quite a simple process. Once it comes, we just need to click on continue. We can check the headset connected is the our once that is done, we can navigate through the port here, but I'll show that here we need to go and we need to click on inside environment, clicking on MetaQuest, clicking on device, and it has just set out my section and just click over it. And you can see now the detected XR system is now showing MetaQuest tool. Now whatever operations that I will be selecting out in my screen, I am seeing the same in my VR view. I can also cast the screen, but to cast and to show on the same desktop that is quite difficult. So we just need to click on create. Now there are multiple projects that I'm currently working on in the VR headset. But to show any such example, like to show or dispel this, I'll just double click on the project file that we have worked on. And now we have two sets of operations. The first one being the show desktop camera project. So whatever you are seeing, the same view I'll be seeing in my VR headset. But the vector will take the follow view. So now whenever I will be validating that whatever movement I'm doing in my software, you will be seeing it in the screen live. Whenever we are streaming it live on Meet and all, so there's a lot of lag being that, but since we did the software, it's smooth. How we can check that we can record the particular session. Once the recording is completed, we can just show how efficient the software has been of in terms of data generation, in terms of doing the segmentation. So this being said, this is the process to set up the VR headset. Here we can go to the image quality. We can set the image directly with the virtual environment, and we can also choose the particular voice elevation. So there are multiple options that we can check over here. We can also reboot our XR system if we are new with the software. So what we can do is we can click on this tooltips option. Now, whenever I will go inside my headset, now whenever I go inside my headset, inside my headset, I have tool text off. So you will see whenever I move my controller, there are multiple options. So we can check corresponding which button for which feature, how we can clean the data set, how we can the data set accordingly, how we can move it into the view, it can be checked off. So while press the critical, if I move it up, you can see the view right now. So these are the further specifications that include, and when I will operate it at the right end also. So there are all the options that we get when we can use software. So this is the easy and the initial ones, the pro level about the software, how we are using. If we are using, I can say that we are following all the types of image processing software, whether being a studio or whether being a streaming software. Also, I had worked on other, uh, I had worked on couple of other VR-based documentation software also from Elucis. I found this most efficient one to be operated on, and this just being said is one such term that we can work on, one such technology that can be further used in the field of research. It's not being used that much, uh, but UCLA is using it, then Cambridge is using it. So no, Indian university has adopted it as of now, but we are in talks with IIT Delhi and some of the AIMS institutions. They are willing to adopt such technologies for their research part. So it can be used widely across different domains. The processing is quite simple when we are dealing with the data set. And in the second coming session, we shall be focusing on specific how to carry out and on orthopedics data set, how to carry out and work on the cardiovascular data set, how to do the tumor detection. And furthermore, uh, since many of our participants are from the research background, how to use the particular software in such purposes to generate out the report to export out the STL file that can be later on used for doing the particular FE analysis, CFE analysis, whichever is required for. We shall be also seeing the designing code of operation and uses. I just require some time to modify some settings so that there's very little of lag between the software and the streaming platform. So right now I'm opening the session for question and answer. So if anyone has any specific query related to this VR, you can let me know. So I'll be very happy to sort it out. Fine. Does anyone has any query? Also, maintaining of conversion is simple process. You just need to mail me or you can just contact me over WhatsApp. It's quite simple as compared to the simple that we have. So even if government wants to use in the rest of you, they can contact us over there or you can contact me over this email ID. So I've shared my email as well as my contact details. You can carry out your queries if you want a copy of the presentation or the installing guide or even the literature behind this PR-based software. So you can just let me know. I'll share the with you whichever time it's convenient. So please ask the queries. Anyone? So I think there are no queries as of now. If there are any, you can also let me know in the second session. I just need to do recalibration of the system. So we'll meet everyone. Good afternoon. I hope everyone will join and we can see the live demonstration on the software. So thanks everyone for joining. I think we can end this meeting for thanks. Thanks.